My question was draw a multipolar neuron. All right. All right, this is my multipolar neuron. This right here would be the cell body, contains the nucleus and other organelles. These little tentacle things are called dendrites, and their function is to receive electrical signals. Well, to receive signals. Their function is to receive signals from other neurons and others, like cells and tissues. This blue thing right here is called a myelin sheath, and they're not on every like neuron. They're only on some have it, some don't, and all they do is speed up the nerve impulse throughout the cell. This little bridge thing called an axon, and this is where the action potential occurs, and like when action potential happens, it travels down through this. These little things at the end is called an axon terminal, and these are where they connect to other dendrites on other neurons, and they they send out neurotransmitters. And sends signals. And yeah, they send at the axon terminal, they send signals to other neurons and target tissues through neuron transmitters by way of using a dendrite, the tentacle things from another neuron. Okay. So when a signal comes in to that neuron, it starts here at a dendrite. So the dendrite gets the signal, travels through the cell. Once it gets to here, and here the cell is negatively charged. And outside is positively charged. And on the cell membrane, there are potassium gates and sodium gates. So when a nerve impulse comes through and is strong enough to trigger an action potential, the sodium gates open up in a certain area, starts at the beginning, sodium gates open up, and it allows for sodium to flood into the cell, causing a depolarization, also called action potential, to occur. And inside the cell, it becomes positively charged now, and outside is negatively charged. It's taking the sodium from outside the cell and bringing it inside. So once the action potential occurs and is strong enough to go throughout the cell and so on, it continues throughout the axon. Once it's met its threshold in that certain area, so like let's say it gets down here, it continues continuing through the axon. Repolarization occurs behind it where it currently is, and the sodium gates closes and opens up potassium gates, and sodium now exits the cell, causing it to go back to a negative charge, causing a resting potential. Now, once the action potential reaches the end of the cell to like the axon terminals, all right, so now once the action potential happens throughout the cell and it goes to the axon terminals, which connects to other dendrites of another neuron, another cell. So let's say this is our cell. It's our neuron. They attach to the axon terminal, which has neurotransmitters, and they bind to like other receptors, sensory receptors, and like target tissues through a synaptic cliff. And this is how signals are transferred throughout neuron to neuron or neuron to tissue.